Hello, everybody, and thank you for joining today's Zcash Arborist Call on September 4th. On the agenda today, we have core stack updates from the Zcash Foundation regarding Zebra, updates from ECC on Zcash core libraries and Zale. We'll hear from the Zingo Labs team on Zano and touch on Zcash deprecation. Under the research and implementation updates, we have someone from Kedit here today. We will hear from Shielded Labs on the network sustainability mechanism as well as Crosslink. And then we will have time at the end for open announcements and discussion portion. What are Arborist calls? Arborist calls are bi-weekly calls where Zcash protocol contributors convene to discuss upgrade timelines and process, protocol R&D efforts, design and implementation of new protocol features, and identify blockers and unresolved issues. The purpose of these calls are to make core Zcash development accessible for a wider set of participants and provide more transparency for the community at large. Anyone interested in learning about the Zcash protocol development can register at zcasharborist.org to participate. And if you'd like to suggest a topic for discussion or present an in-depth agenda item relevant to the Zcash protocol, please email arboristcall@zfnd.org to request a slot. Other ways you can get involved in the community are to check out Zcash community grants at zcashcommunitygrants.org, hop in the Zcash R&D Discord, and jump into the Zcash community forum, and you can find all these links by going to zcasharborist.org. And we'll get started on the agenda, hearing from the Zcash Foundation on Zebra.
Yep. Hello. Since the last Arborist call, the main things that happened in the Zebra code base was that we added missing in orchard and sprout fields to the get route transaction RPC. So hopefully it should be complete now. We also completed the zget tree state RPC, which was missing one of the fields. We also migrated Zebra to use a layered configuration. We changed libraries to handle configuration. So you can still configure Zebra by using a TOML file, but you can also configure Zebra using environment variables, which is good for to make easier for people to deploy Zebra, and also makes easier for us to do our own CI. But that's optional. You can choose wherever you want to use environment variables or the config file. And we also switched Zebra to use the Zcash sapling verifier. Previously, we didn't implement like the proof and signature verification, but we handle all the logic to call that. So we removed all the logic and just call the Zcash function that validates a sapling bundle. So with that, we managed to remove a bunch of code from Zebra, which is good. And this is something that this has been happening in multiple places in Zebra. The goal, probably at some point, we want to remove a transaction type and use the Zcash type, but that's probably like the final step of the whole thing. But yeah, we've been replacing some stuff that was duplicating Zebra with Zcash types. That's mostly it. There's a lot of work going on, work being reviewed. Our review queue is a little big right now, but yeah, hopefully we'll manage to get those merged soon. So yeah, our focus has been on finishing up some small RPC things that I went over the RPC spreadsheet that we have and noticed some stuff missing, so we've been working on that. And also we've been refactoring CI, which will take a little bit also. And hopefully with all that done, we can help focus more on helping with Zalet or Zeno or whatever needs to be done to finish the cache deprecation. That's it.
Thank you, Conrado. Any questions for Conrado or the Zebra team? All right, we will jump ahead And next up is ECC.
I can do that. So let's see. We prepared 48, which is about generating P2SH multisig addresses, which is needed for NU 6.1. Sent the draft of that to the Keystone and Ledger devs and got positive feedback from them. So that can go ahead. We've been preparing for the Zale Alpha. So that involved implementing RPC calls, reporting and working around some issues in the Zeno and Zebra stack. And also we investigated a few bugs reported by users in Zashi and Zcash. Let's see, Stradon, Chris, did I miss anything?
Yeah, the main things are so we have there are just some sort of community-wide relevant things. One is that we have opted for at least the Zale Alpha and hopefully going forward to implement all of the functionality that's needed for transaction inspection as part of zlist unspent, or excuse me, zview transaction. So that hopefully the get transaction method, which has some extremely confusing semantics in Zcashd, will not need to be used anymore. The same thing is true of zlist unspent, taking over the functionality for listing all unspent outputs so that list unspent can also be retired. Beyond that, the last steps that we have are to get the last bits of the Zcashd wallet import in for the alpha, and there are a few pieces of cleanup to be done, but in general we're getting relatively close.
Yeah, so the focus will be on releasing the alpha, getting feedback from the alpha, and also releasing the Zcashd that supports NU 6.1 on mainnet. And we should have our hands full with those things.
Anything to add, Strad?
Nope, I think everyone else got it.
Okay, cool. Thank you, guys. Any questions for the team? Double check the chat.
Actually,
okay.
There is one
Yeah,
thing that I'll mention, which is that one of the long-standing annoyances we've had with the mobile SDKs and Zashi and sort of the Rust stack and behind it has been the inability to separate out the need to select an anchor height for reliability purposes from the need to select a particular confirmation amount for security purposes for untrusted received notes when you go to spend them. That is now finally making its way through the stack as an implementation, thanks to Shell, the new ECC engineer who has taken this as their first onboard task, and it is working its way through the various stacks now. And so hopefully in the next short while, we should see updates to the mobile SDKs that enable the wallets using them, such as Zashi and Edge and others, to be able to ideally just by default have faster spends of change notes.
And now that you've mentioned that, now I've remembered other things that we've done. So one other piece that built on top of that was Paku's PR to add send max functionality to Zcash client backend has been merged and so is available for use. We will be cutting Zcash client backend and Zcash client SQLite releases and I think we need to do another PCZT release soon.
That would probably be concurrent with rolling of the stack for the mainnet 6.0.
Yes, yeah, that's probably when we will do that. And then the other thing that that is a significant piece of work that that Paku did some help to facilitate was we've merged the in-memory wallet implementation that was done by ChainSafe There is still work that needs to be done to fully bring that up to date. There were a number of things where APIs are changed, and we've essentially just left panics in place for things that are unimplemented, where there are updates needed. So anyone who's interested in, I think that ChainSafe has a grant that's starting for maintenance, but that is now at least that code is no longer bit rotting, which is really nice.
Yeah, great. Yeah, on that, we already pointed ChainSafe folks to that direction so they can fix those in their next maintenance cycle, which is, I think, starting next week.
Perfect timing.
And one more thing, we've finished the changes to the protocol spec for NU 6.1. It's still in the PR, but they're done. Apart from the mainnet address for the disbursement, which has not been generated yet.
Great, thank you all. Any questions or comments? All right, check the chat. Yep. Okay, so up next we have Zingle Labs on Zano. That's Za.
Yep. So we have finished our respec grant and proposal and pushed there's some requested features in front of the Zale developers who immediately opened a raft of issues, which we are now prioritizing and triaging to make sure that Zale Alpha can still come out in the coming weeks. We've also backlogged a fair bit of architectural redesign in Zyno to promote a bunch of internal types into the type system so that we can get proper guarantees from the compiler. That work's already been done, so we should be benefiting from that shortly. We're also working in Zinglib to upgrade to support network upgrade 6.1, which we should have support for hopefully before the end of the week. And I think, yeah, that covers what we have.
Thanks, Za. Any questions for Za or comments on Zano? All right. Jump ahead. Zcash deprecation updates from the whole squad. This is probably Paco first. Yep.
Yeah, I think that a lot of, as always, a lot of things have been covered on the previous updates. We are continuing with the outreach for the network upgrade friction survey, getting some initial feedback from some exchanges, and I will continue to keep pinging and annoying people to get more responses. For us, it's super important to have this input to really know the scope of transaction changes, for example, and on network upgrades, and how these partners handle those changes, and how we can like make them less of like an event and more like something that just happens and it's no problem to them. And this will be used to scope some RFPs if needed. So we'll continue on that. And then on the testing front, Alfredo today presented a really cool testing framework that he's been working on and wrestling a bit, which is a huge work, and he deserves like a lot of credit. And yeah, I can't stop like congratulating him. It's currently living on the Zebra RPC code base, and I think it's going to help us accelerate a lot of the RPC work, which is like pretty repetitive and was kind of lacking a good quick feedback for developers. So there's there are Zingo folks already looking at it and seeing how they can benefit from that. And yeah, then we're triaging bugs from the integration. Some things are breaking, others are like slightly doing some bangs and noises here and there, but nothing that, I don't know, one wouldn't expect from an integration of two pieces of software. So that's kind of what we're at right now.
Thank you, Paku. Anything else on Zcash deprecation? Okay.
For Zcash deprecation itself, it's likely that we will potentially put some more deprecations into parts of aspects of Zcash in the next release. If we have time, it mostly comes down to that, but expect that there will probably be some more things that get marked as deprecated but enabled by default for things that are intended to not be provided in ZALE. As we figured out more of the service and how things are shaping up, and in particular what things are very tricky to actually provide within ZALE. So
exactly, we needed to do that exercise in order to figure out what to deprecate in Zcash basically.
Yeah, so it's likely that there'll be additional deprecations in there as part in the same release as mainnet Zcash. It mostly comes down to we need to focus the energy on implementing the things that are necessary to implement in ZALE to be able to get people to migrate at all, versus implementing absolutely everything to make the migration seamless. I'm trying to still ensure that we implement as much as we can to make the migration as seamless as possible, but it's not. None of this is going to be perfectly seamless, and so So the thing to be tracking in particular for this is I don't know if it was in the last 2 weeks or before that, but there's I think it might have just been before the last call. There's a ZALE book page up now. Just go pull that up.
I think it was mentioned briefly.
Yeah, but there's now a page there that has all the altered semantics, and we're updating that as we go. So basically, any time we make a change or renaming fields, adding fields, changing semantics of fields, still going there. So keep an eye on that page in terms of when anything ends up happening, and if you're running into things. We're not going to get that page to be empty. But that page is the minimum delta we'd like to get to. To clarify, these are also not the RPC documentation. The RPC documentation, that is something that we will consider potentially trying to pull out into an automated page. Like we're writing RPC documentation in the crate, like as we so it's definitely a lot better than it used to be. And that is accessible via the OpenRPC endpoint. So that is all introspectable automatically. It would be nice to get that up, but it's not currently a priority to get the new, like the RPC's documentation to be rendered up there, but that would be a nice contribution. But yeah, the main thing we're tracking is just the delta between Zcash and ZALE.
I'll file an issue for that because there isn't already one.
Yeah, thanks.
Alfredo?
Yeah, I think eventually Zebra and Zeno should use the OpenRPC sync to document the API, so the user will have a unified way to find RPC methods.
Yeah. Yeah, there's a bunch of stuff related to that we could probably standardize on a particular way of doing it and then extract out some common logic into helper crates. But yeah, at the moment, I haven't had time to work on that. So copy and paste.
Right.
Also, maybe
for now.
Yeah, there might already be a project to provide a friendly interface over an open RPC.
We're using the one that I could find. I have not found anything better.
Right. Okay. Fair enough.
Yeah, I was playing with it yesterday, and the official web like web UI application for the RPCs. I think the spec for ZLA is already too big for the web app, and it doesn't like kind of work. Yes, but I assume that if you actually query the RPC exploring or discovering method of the OpenRPC spec, then those kind of clients will work, and then you kind of get these clients for almost free, which will be nice for developers to just to play with it quickly. Yeah.
Or we could fix whatever the bug is in that visualizer that because it's running out of memory.
No.
Well, someone else could.
We can file the issues. We can
broad
file the issues that are needed for them to fix that.
So in Zebra, we use an OpenAPI Swagger, which is not for JSON RPC method, and we are waiting to change to the one Salad is using. But we're expecting you guys to fix all the problems it has before we can.
Probably, yeah. Like the whole the infrastructure that I wrote to make that work, like it could easily be pulled out into a crate with just the macro logic for it. It's just a matter of having time to do that. I will probably do that at some point just to make it easier to maintain.
All right, thank you all. Anything else on Zcash D deprecation?
No. I think all the things have been covered, and also I don't know someone that hasn't listened to this yet in any of these announcements is that we're as first principles, we're not trying to do like a plug and play one by one replacement of Zcash D. There are a lot of things that if engineers ported them as they are, they will be actually working to develop tech debt of another system into the new one. So we want to, of our first principles, avoid that and try to make things as frictionless as possible without like bringing a lot of like baggage from the old system. So I know that will be a dream to have everything just work as magically, but we'll try. But we want to not bring tech debt to the new place.
Thanks, Baku. All right. Jumping ahead, normally this is in the morning calls, but we do have Pablo here. Anything on the Cadet side?
Hi guys, I would like to share my screen for this.
Sure. Can you guys see that Pablo's screen, or is it still mine?
Still yours.
Still yours.
Okay, give me a second. Okay. Go ahead and give that a try again, Pablo. There we go.
Okay guys, so there is a lot of things going on around ZSA, but the important things for this meeting are Orchard. So Orchard, as of now, it is spec complete. There were a couple of changes in recent weeks, specifically the zip editors added versioning for the SIG hash, and we did some small but meaningful changes to the issuance keys. Both of these changes are now implemented in Orchard, and we have a complete package. It is spec complete. We are doing a final sweep on this in order to reduce the diff as much as possible. In regard to reducing the diff, there is no right answer there. There is a trade-off between smaller diff and the proper structure. So we are internally debating between smaller diff and what we believe is the right structure. A few more days from now, we are going to submit, we are going to mark the Orchard ZSA PR. We're going to change the mark from draft to ready for review. It is already spec complete, but the diff reduction is the final touch that we are doing. And then the review part. Of course, we are here. We are available to support the review. The review Orchard ZSA built on top of Orchard is a big chunk of work. So we identified 3 areas that can be reviewed in parallel, namely the Orchard ZSA circuit. So the Orchard ZSA circuit didn't change since the audit that we did half a year ago. So it's a good thing. It is stable, and it seems that no more changes are required for the circuit. This can be reviewed independently from the rest of the changes in Orchard ZSA, and it's a good thing. It will help with the review process. The second thing that can be reviewed in parallel is the Python reference implementation. So we updated the Python reference implementation to support both Orchard ZSA and transaction v6. Transaction v6 is a different topic. I will discuss it in a moment, but the Orchard ZSA part is there and it is ready for review. Same as the circuit, it can be reviewed independently and in parallel, which is also a good thing. And finally, the Orchard ZSA built on top of Orchard. It is the same crate. Now it can produce Orchard bundles in a backward compatible way, meaning if you take our Orchard ZSA implementation, you can still produce the good old Orchard bundles to be inserted into transaction v5, or you can produce the new Orchard ZSA bundles to be inserted in transaction v6. And this is the significant chunk of work to be reviewed in one go. This will require a significant effort to review, but we knew this in advance. We are prepared for this. We're here to support this review. Of course, we are here also to make the changes necessary. We started the discussion around the Orchard ZSA review. Strad and Chris looked at this. They confirmed our approach to generalizing Orchard to support Orchard ZSA. So the general approach is there. The details, the devil in the details, we will discuss the details with them, with DCC, as much as needed to make it production ready. We are there just for this. So this is on the subject of Orchard ZSA. On the subject of integration, so Orchard ZSA is a piece of the puzzle, but also the upper level, the layer that is on top of Orchard ZSA is the transaction v6. So we and the ECC team put a lot of effort into transaction v6 to make it future-proof. First of all, to support Orchard ZSA, but also to make it future-proof with the features that we believe that will be embedded in the future. We are aiming for a transaction format that is that will support other features except Orchard ZSA, but our implementation at the moment. So we have a reference implementation for transaction v6. Currently, we just made it work with Orchard ZSA, and we ignored all other NU7 features, namely NSM and change for fees. In the recent weeks, in this week, we had a very nice, very good discussion with DRM and Strad, and we decided that instead of ignoring everything else, we are going to embed all of the spec for transaction v6 in our reference implementation. We are going to embed the required fields for NSM, and we are going to embed the fee changes, and we are going to make our implementation for transaction v6 spec complete, meaning we are going to take zip 230 and make our implementation spec complete with this zip. And this is in order to support the integration efforts as much as possible. So while this is in review, we can move forward and advance NU7 as much as possible, namely by embedding everything needed into transaction and into TX version 6. So we are going to make it spec complete, and after, of course, the transaction v6 is dependent on Orchard ZSA. There is no point reviewing this unless this is already reviewed and verified and merged. So while this is being reviewed, we are advancing with everything needed with transaction v6, and this is what we agreed just this week. So there are two pieces here. First of all, there is the Libra Zcash implementation for transaction v6, and there is the Python reference implementation. We are going to update them both. The Python reference implementation is very nice. It's like easy to review. Again, easy in the sense that it is much easier than the real thing. So it's a good starting point for everyone that want to be familiar with the transaction v6 format implementation. So start with the Python reference implementation. Once you got this straight, go to the real code and look into Libra Zcash. But we are going to do this for both. This is
It's surprising how simple the Python code can be, because we're used to crypto code being complex because it has lots of optimizations, and the Python code just doesn't. So it's actually very nice, and it could be written very quickly, which is how it ended up getting written. So yeah, carry on.
Yeah, indeed. Part of the reason that is relatively easy to implement and review, there is no external dependencies here. While here we have a bunch of external dependencies, or just to say other grades, note encryption. Here, everything is embedded inside, so it's like self-sufficient in some sense, and easy to review, easy to implement, easy to change. So
apart from things like hash functions.
Yeah. So we have this. This is on the subject of TXV6. Also, we submitted the draft PR for Libra Zcash, so everyone can see how it looks from the Orcha ZSA, from the ZSA point of view. So there is a draft PR here. Again, it implements transaction v6 without all the fields, just the ZSA material, but soon it will include everything needed for the new transaction structure. So this is on the subject of Libra Zcash. On top of this, we have Zebra. Zebra is the topmost layer. We are in the process of implementing last pieces for global state changes. We had a discussion with the Zcash Foundation this week about what's the proper next steps. We are implementing the global state changes for ZSA, namely, so the node now needs to keep track of all the assets, right? At the moment, we have just ZEC, transaction v5, and after the next upgrade, the next upgrade, the NU7 upgrade, the Zebra node needs to keep track of all the assets, all the issued assets, and this is what we are we call the global state. First of all, it needs to be keep track of the supply for all the assets being issued. Then it needs to keep track of all the assets that was finalized. Meaning, if you want to issue an NFT, then you issue an NFT and then you finalize. And then it's like a one-time seal, you break it, and you cannot issue more, and this is guaranteed by the consensus. So the node also need to keep track of this part of the global state. And after you, this is a change to the database. The node has additional table for these assets now. And on top of this, we need to run the consensus rules, meaning, okay, someone issued some assets, and then someone tries to issue more of the same asset. So by issuing more, the node needs to check whether it is permitted to issue more, namely if this is the right issuer, if this is the right signature, and if the asset was not previously finalized. So this is included in the consensus rules. This is also in final steps of implementation, but because this is dependent, the dependency here is Libra Zcash, and the dependency here is in Orchard. So yeah, we have a working version, but as long as TXV6 is not finalized, as long as Orchard ZSA is not finalized, we cannot call it final version. So we are calling it working version. So we have a working version of this. Final consensus rules are being implemented. And in addition to this, we had a discussion with the Zcash Foundation team this week. We proposed the new health RPC endpoint. So we have a running testnet for ZSA. And every time we put the Zebra node inside the Docker container, so most of the automated systems require some kind of automatic indication that the process inside the Docker is working correctly. So we proposed to add the health endpoint. We already implemented this internally, but right now we are in discussion with Zcash Foundation if they would like to include this unrelated to the ZSA work as part of the Zebra node. This is in discussion. It's a good idea to have all the RPC endpoints all the RPC endpoints in Zebra at the moment are post endpoints, and automatic systems for deployment health endpoint, which is get. So the proposal was to add a health endpoint, something very simple, like get health, and if the node is up and running, it will return the proper get response. So we are going to submit a PR independent from the ZSA work to Zebra just for this cause. This is in discussion. Again, this is in parallel to the ZSA work that we are doing. I think this is pretty much everything.
Thank you, Pablo. Questions, comments on ZSAs? Yeah, go ahead, Paco.
Yeah, well, thank you for this update. It's great work, a ton of work. I'm interested in knowing a little bit more about the transaction basics work and the Python reference implementation. Do you is this Python reference implementation intended to be like a guide for people migrating into or adapting their systems to accept V6 transactions or to be able to understand them? If not, would you be able to actually produce that kind of documentation as well? We've gotten some responses from the survey, and I think that will be useful for some organizations.
Yeah, for sure. The Python reference implementation is a piece of code that emulates emulates some parts of the Zcash protocol, the significant parts. It already includes most of the parts for transaction v5. This is already here in Zcash under Zcash test vectors. What we've been doing is taking this work and extending this to support transaction v6. So the idea is to have two implementations. It started as a concept like not put all your eggs in one basket. So the Zcash people previously, before we started the ZSA work, implemented most of the important parts of the protocol in both in Python and in the real thing in Rust. We took
So just
go ahead, Dave.
Just to clarify the motivation, I mean, this is nowhere near a production implementation, and this is it's the purpose of it is to be. I mean, it's not quite a reference implementation, but it's to be the most straightforward possible implementation of the cryptography, mainly, and things like format passing. So that you can, it's sometimes a lot easier to understand than the, well, as it was C++ in Zcash or Rust code, because that, as I said before, has a bunch of optimizations. So yes, it's not that it's an implementation that you could use instead of any part of the Rust or as it was C++. It's just for understanding, really, and it's understanding of protocol developers rather than users of the protocol, really. So I'm not sure that it's that useful for
that's
changes and things.
So so for the transaction part specifically, the goal of the purpose for which we added both the legacy transaction format and the v5 transaction format into the test vectors repo was so that when people were implementing their own parsers, they had or could generate test vectors that exercised all of the ways in which the transaction format could alter. That's the purpose of it being a test vector generator. Yeah, it's not really a reference implementation. It's a test vector generator. And so, and what that defends against is that we can say to anyone, here's your transaction. You're doing a transaction parser right now. Here are the test vectors that your transaction parser needs to be able to parse in order to be able to tolerate any transaction it might see on the network. And if you're unable to parse parts of this, like we've had, for example, exchanges in the long past where, like when expiry heights were added in v3 transactions, they just hard-coded them to 0 in their parser, not just in their serializer. So they would either incorrectly parse transactions or just downright fail to parse transactions that set an expiry height, because they would only parse a transaction where the expiry height field was 0 and the shielded parts were, their lengths were 0. They didn't implement a full parser. And so I remember like users coming to us back in, this would have been like 2019, I think, with complaints. And it's like, well, the problem is they haven't implemented the full transaction specification. They've only implemented the bits that affect the transparent side. So that's the intention of this, of the test vector generation here, is that then we can say, if you want to know if you've implemented things correctly, can it parse these examples? They are meaningless, like they are not valid transactions, but they are valid transaction encodings.
Yeah, it is not a complete implementation, but it gives a very good guarantees, and most importantly, it is independent of the Rust and the C++ code. and it can be inspected independently. So if the test vectors generated by this crate passes, if the node passes under these test vectors, we get a very good guarantees toward the spec compliance. So we took the already existing ZSA test vectors implementation, we call it Python reference implementation, and we extended it. Right now, the Zcash test vectors produces transaction v5 test vectors. We extended it to produce also the transaction v6 test vectors, including everything that that we did for Orchard ZSA. Our implementation takes into account Orchard ZSA, but as previously discussed, it's going to take into account the complete spec, meaning zip 230. Every field for transaction v6 is going to taken into account in our implementation. Eventually, it's going to be merged back into Zcash test vectors. I hope that answers your questions, Paco.
Yep. Thanks.
Sarah, you still have your hand up, or was that from prior?
That was from prior. I don't
Okay.
actually see how to unraise it. There we
There
go.
you go. Okay, cool. Thank you all. I think we'll jump ahead now. If anybody thinks of anything, we might have some time at the end to circle back. Next up, Shielded Labs on the network sustainability mechanism.
I think Mark's going to give the update today.
Can you hear me?
Yes, now we
Yeah.
can.
Okay, sorry about that. Yeah, I can speak to the NSM. Zip 233. The test vectors were just updated, and I landed a small PR thanks to Chris for the approval. Just to fix the CI so that other PR could get merged. I was speaking about it was just up on the screen, but 101. 109 was merged. 109 walked so that 101 could run. And that's just the NSM test vectors. Once that's merged, which I believe Dara has UT-ACT, then we can move back to Zebra and tackle the central final boss PR for Zip 233. Zip 234 and Zip 235 remain as they were. I think that's everything.
Thank you, Mark.
That I had filed a PR on, the CSF simulation repo to update the it's IGACO / CSF because it's not been renamed to NSM. I'll just link it in the chat. So if you could have a look at that, then that would be useful.
I don't have IGACO permissions, I don't think, anymore. But somebody might. I can definitely take a
I mean, alternatively, you can just use my fork, which is Dara / NSM -simulator.
Okay, awesome. Thank you.
Any questions for Shielded Labs or comments on the NSM? All right, we'll jump ahead to Crosslink.
All right, that is me. Let's see. So last week we did a Milestone 2 workshop, and that had some hiccups, but overall it went pretty well. We got multiple people on the network and syncing, and so that was a demo of where
like the key test for the demo is we try a rollback past the finality point and prevent that. So it's like hooking up proof of work and proof of stake to refer to each other and provide that finality. But there's no proof of stake accounting stuff. And that was fun. We also had Dismad and Merrick show up in person, which is cool. We were all at an on-site. But we had a bunch of hiccups, so it was some people got confused with Discord. Some people, I think a lot of people couldn't hear. I didn't know that, so I just kept talking, as one does. And there was a bug that was pretty persistent, but fortunately, it didn't like block the overall progress. And then what else? So, overall, it was a mixed bag, but it was exciting to have people in the workshop. And so this week, we're starting on the next milestone. So milestone 4, if you look at our roadmap on our website, is basically now we add proof of stake. That is a much bigger like footprint than the other changes we've made so far. And so we have been figuring out how to break that one up into smaller pieces. And so given that the workshop last week had all those hurdles and confusions and stuff, we're just going to spend the first part of this. So we made a milestone 4.1, and it's just focused on making a test net that's easy to join and it has good instructions. And the functionality change we want to make is we wanted to add a Zebra RPC call that basically says, put me on the roster with this weight, where you can just make up any number. So it's sort of like, it's a test net. And so that should be functionally the same as the last milestone demo, except the goal is that it should be a lot easier for people to join and check out. And we're also improving, like doing some CI improvements and things like that to just make that whole process better. And then moving forward, oh yeah.
So do you trust me exactly this much?
Yeah. Say it again. Oh,
do you trust me exactly this much?
Right. So we might, our philosophy, since this is just totally an experiment prototype right now, is if people break the test net, then we'll think about if we want to make it more resilient.
Yeah.
Let's see what else. Okay, so our goal is hopefully within a month to do another workshop that's almost like a repeat, except it should be a lot smoother. After that, we want to work on introducing like the first piece of staking mechanics. So that would be a way to bond and unbond with transactions, but it won't have like all of the rules like an unbonding period or details like that. So stay tuned for that one. I think we're calling that 4.2. And then after that, there will be yet another milestone, at least one that adds some more wrinkles to the proof of stake design. Meanwhile, I think we have a blog post coming soonish, unless I already missed it. Sorry, I'm a little bit tired. I'm solo parenting this week. We have another blog post coming out where it's sort of like an answer to a FAQ of what the proof of stake design is. It's not actually the design, but like what are the implications? Like it's sort of targeted for a user, like how do I stake and unstake and what does that look like? And it's all very provisional because we haven't actually hammered out the specific concrete design yet, but we just wanted to get our thinking out in front of people to see what feedback they have. And I think that's it for the update.
Thanks, Nate. Any questions or yeah, Dara?
I have a question. So how are you approaching this as an economic mechanism design problem? How are you going to analyze sort of the staking part of it?
We are, so basically we plan on looking at that much more like stringently after the prototype phase, so like after the end of the year. Which means the design we're making is just sort of, can we make the simplest thing? Like we have a few different trade-offs and goals, and then we've continued to try to simplify it over and over. So like, for example, a very broad simplification we made is, well, a lot of Cosmos style proof of stake chains where users can delegate, they have, you know, a sophisticated protocol. It might have slashing, or it might have fees or penalties and unlock periods and stuff like that. But it also is sort of predicated on the users who are delegating responding to bad behavior and like moving their delegations away. So we're making this broad simplification. Like if we're gonna rely on the users to do that in some cases, why don't we just do that across the board? And so we won't have rules for lots of those edge cases in order to try to keep it super simple for now.
Okay.
I should mention though that I have become a little more concerned about privacy. And so we do have a wrinkle that's motivated by privacy partially, which is a unbonding period. But we can say more about that when it's a little more baked.
Interested to hear about that.
Or we can go into it maybe.
Well, we can do that at the end if we have time.
Yep.
Okay, that works. Thank you, Nate. Last call for cross-link comments or questions. All right. Any open announcements from anybody? Strad.
So we had hoped to do at the there's a Zcash deprecation meeting that we've been running sort of weekly, but I forget exactly how frequently. And we'd hoped to do a test run of like usage of Zale at that, but there were some blocking bugs that meant that we couldn't run that. But that will likely be happening in the next week or so. So if you are interested in like getting playing around with the pre-alpha, or maybe it'll be the alpha at that point. We'll see how quickly we can get the first alpha. Then ping in the Zcash R&D Discord, and we can let you know when we're doing that. It'll basically just be like hands-on with Zale and using it and playing with it, and potentially like sending each other some funds with it to exercise the various workflows that we've got there.
Cool, thank you, Strad. Any other announcements? Okay, and last up, open discussion. So we could loop back to what was it, the unbonding privacy bit, Nate, or there might have been something from earlier in the call that I apologize, I forgot. But if anybody has anything, we can jump into that after Nate.
Okay. Yeah, so the thing that shifted is previously we were imagining a fairly simple system. So we have certain constraints, like we're not going to change any zero knowledge circuits, and that's primarily motivated for keeping the changes simple and safe, and being able to iterate and deploy faster on the V1 of the protocol. And I had modeled that kind of incorrectly, as what that means is the staking delegation positions will have visible amounts, but no addresses associated with them, or maybe like a one-time use address for unstaking. And the incorrect modeling I did was, well, that's roughly like a turnstile. And we already have kind of a best practice and some practical knowledge of how to manage turnstiles. But talking through the design, approaching this milestone, we realized it's different than turnstiles in quite a few ways. So one is that it basically reveals more information. So one is it reveals who you're delegating to, and also there's just a timing thing. So a turnstile event is just a single transaction, so an amount is revealed, and that's that. With this, though, there's the timing of creating the delegation and removing the delegation. So the wrinkle we were thinking about introducing, which would complicate the super simple design, is to sort of quantize when delegations and undelegations can occur. And then also adding an unbonding period. And that has a couple of motivations, but one of them is people who want liquid Zcash and they don't want to wait for that amount of unbonding period will then likely hold that Zcash in the Orchard pool directly. So yeah, that's the gist of it.
Have you considered just taking the private staking design from Penumbra?
We talk about Penumbra a fair amount. I haven't looked at the mainnet design yet, but when I looked at it early on, like a couple of years ago, it was predicated on a few things. So one was, I'm pretty sure, I could be wrong about this, but well, the thing that I'm certain about is that the design I read had, there is a unique asset for each validator, and then staking and unstaking is, or sorry, delegating and undelegating is equivalent basically to buying or selling that asset.
So we will have part of the machinery needed because we will have CSAs presumably by the time we need them for staking. The other part of it that does require circuit support, usefully we did an audit of Penumbra, so we understand how it works. So the other part of it is that so those assets are kind of treated specially because they, when you delegate and undelegate, then you need to apply a conversion depending on the amount of time that's passed. But that is a very simple circuit change. So you could consider maybe doing a simple thing to start with, and then when we have time to do that circuit change, we could potentially improve the privacy by baking that into the circuit.
Yeah, I just realized I had gotten confused because I thought that design required or relied on a DEX, but I think it's simpler than that, right? It's just when you delegate, the protocol just says, I know how many of the foo validator tokens you get for this many Penumbra
it's
tokens.
Like I mean, it kind of is a DEX, but it's baked into the protocol because it knows exactly what the exchange rate should be.
Yeah, I like that idea. We actually did talk about it early on, like at the beginning of the first milestone, and we thought it seemed a little bit too complicated, just in terms of just, for our 1.0 goal.
Yeah, for 1.0, I agree with you. So yeah, what I'm considering doing is kind of do transparent delegation to start with, and then add support for private delegation.
Yeah, I think
because
that's worth
it
considering.
really isn't a complicated circuit change, because it doesn't.
Okay.
It's not really cryptography. It's just a conversion of amount. But, yeah.
Right, which happens transparently anyway, right?
Yeah, and you can still get it wrong because it's arithmetic in a circuit, but circuits are complicated. So, anyway, we know how to do it, and we can just look at the penumbra circuits.
So we do, yeah, yep. We do. Oh, wait, I thought they used, I thought they were based off of sapling. Is that?
I mean, the proof system doesn't matter. You can take the design, and the design is sort of what you
Got
want to
it.
be looking at, really.
Okay. Yeah, we'll definitely consider that. We haven't really started working on like a post 1.0 thing yet, but we want to start figuring out what that would look like, and so this would be a candidate. There's a GitHub label for like post 1.0 wish list items, so I'll make sure that's there.
It occurs to me now that I think about it, there might be an interaction with the long-term storage protocol we're thinking of. And I actually sort of made a start on a rough design in a HackMD somewhere. So
Wait,
because
which one is that?
long-term storage protocol. So basically the idea is that for the existing protocols, we're eventually going to want to deprecate each of them because they are very complicated, and they use cryptography that's dependent on elliptic curves, so they're not post-quantum, and they're kind of over-optimized in some ways, and we know how to do things more simply now. So there's a case for having a protocol that uses simpler cryptography, and in particular doesn't need to use public key cryptography because it's always the party that knows the same keys that is withdrawing as originally deposited the funds. So you're only withdrawing your own notes, but you can spend them to an arbitrary place because it's only the spend side that changes that. So I think that's a good idea. I think it's the right way to evolve the protocol. But if you do that, then you obviously want things in the long-term pool to be able to be used as staking funds. So yeah, I'm just sort of pointing that out because you need to, we'll need to think about how that works.
Yeah.
And it also sounds like it has a similar privacy consideration.
Yeah, so there's some interesting wrinkles about how turnstiles work, because I think what you would need is a long-term, I've been calling it reservoir, sort of associated with each pool. And then you still have the separation between pools, but for each one you have the long-term protocol that does not get switched off when the complicated part of that pool gets switched off.
Interesting. Yeah, I'd like to see that write up when it's ready.
Yeah, I haven't been able to finish it because there are so many other things to do. But it's simply enough that yeah, I really want to do it because eventually we will need a post-quantum protocol anyway.
And it also means that it's then something that, given what we know now about how to run and manage a private shielded protocol based net payment protocol, it's something that as a community we can potentially commit to actually having the long-term properties that various members of the community assume are present for the existing protocols when they have never been.
Yes.
Okay. Anything else on that topic? Thank you, guys. Nope. Pablo, yeah, go ahead.
On a different subject, I have a question for Deraema. What is the status of the post-quantum resilience ZIP? We are at
Um,
or
I've just been working on it today, actually. So in order to simplify that zip, there are some preliminary changes I want to, refactorings that I want to do to the protocol spec, which I can do on top of the NU6, NU6.1 changes that have just been finished. So yeah, there were there were some dependencies and blockings that has now been resolved. And so I can work on that now. And I hope it shouldn't be too long before we have a draft zip for that.
so we believe that this is a strong proposal. Is this planned for NU7?
Well, it's not an NU,
So
it's not
I haven't done the work to convince people that it should be an NU7. I personally think it should be, but I'm aware that I need to do that work.
But
Sorry.
also it is not a consensus change, so it is not relevant to NU7. It is a change that would be good to deploy alongside NU7 or concurrently with NU7 for various reasons that the rationale of that zip includes. But there is no consensus change involved with it, so it is not part of it. It would not be part of NU7. It is not it does not get tied to a consensus branch ID.
I will correct you slightly there because shielded Coinbase throws a wrench into the
that would be the one thing if we decided that, but that would be a conscious decision, but it's not a necessary requirement for that.
Correct.
Yeah, we can just say you don't, like, if you receive a shielded Coinbase, you don't get quantum resiliency until your wallet then does a subsequent spend. And if the wallets are all implementing it the same way, that would happen automatically.
Right. For simplicity, I think that the simplest way to describe it is as a consensus change, but it's mostly not a consensus change.
To me, that's really confusing. To me, that's too confusing. If you want to describe it that way, I would say the shielded Coinbase part is a separable consensus change that builds on it, but the actual core of the quantum resiliency is not a consensus change. Referring to it to as
You're
such
correct,
is
yes.
confusing.
You're correct.
So there could be some wallets supporting post-quantum resilience and other wallets.
I definitely want to avoid that because that would be very difficult to explain to users the consequences of that. It will be more like so the change that was made to the notes plain text format with zip 212 in Canopy, I believe it was. Yes, it was Canopy. So it will be like that. It will be exactly the same effectively because it would be a version 3 of the note plain text format, and there would be a requirement to implement it for wallets, even though it's not a consensus change, except in the case of shielded Coinbase.
Yeah. It's actually both less and more problematic than the note plain text version change we had before, because the problem there was that some wallet, like there was a grace period, and this was zip 212, and again, it wasn't a consensus change. It was a fix to a problem that wallets started rolling out, and there was a soft coordination period. There was a grace window where wallets would be allowed to make either, and then wallets would start enforcing a requirement.
I think in retrospect, that was a bad idea.
Yeah, because a few wallets that were in popular use did not implement it within the grace period, and so their users then encountered problems when other wallets started generating note plain text that they couldn't receive. So I say it's an easier problem map because the quantum resiliency is unobservable to the recipient, in that it is purely a change that the sender's wallet makes to how they construct their notes. The recipient can know it's been done, they can verify it's been done, but it's fully backwards compatible because all receiving wallets that will be able to handle what notes created in this way.
Actually, I'm not sure that's true of the proposal in the current draft. It was true at one point, and then I decided to simplify it in a way that
it
could be
has
said to break that property.
then that will need. If that's the first
yeah.
I'm learning of this, so that will you will. Need
Well, I need to check that. Yeah, that's just off the top of my head.
Yes, because
we need to be careful about this.
Yes, because at least when we last discussed it, the motivation here was that it doesn't break interacting with, like, paying people, because there's no visible, there's nothing that breaks the recipient side.
Let me just check.
Yeah, but you still want all wallets to upgrade, because if you receive an Orchard note that is quantum resilient in a wallet that doesn't understand it doesn't generate them itself, then when you go to spend that quantum resilient note, it will produce a change note that isn't quantum resilient. So we do want all wallets to implement this and to upgrade. And that's why I said earlier, it would be convenient for this to be deployed alongside NU7, so that we could just say that if you're making a V6 transaction, you also always create the Orchard notes in this way. And that would be convenient from a developer point of view, that we could, for the most part, know that people are making wallets in this way. But there's
so remember that there has to be a note plaintext, a new note plaintext lead byte format anyway for ZSAs.
Correct,
right?
But again, there's nothing
from error bundles.
Yes, but again, there's nothing about that actually forces the wallet to create notes in this fashion. The most we could do is, if we wanted to, there's nothing in the current proposal that forces them to do this in this fashion. If we wanted to force the issue, then we could add a wallet level requirement similar to the note commitment checks, where we say, when we parse this out, we then go and validate that we can reproduce the corresponding commitment from the derived randomness, and if you don't do that.
There is actually in the current draft, RCM is computed differently if lead byte is OXO3. It has to be, because it includes the asset base. But there's almost no point in sort of keeping it compatible if you have to account for the asset base anyway. Everything has to be upgraded for ZSAs.
Yes.
And therefore, you might as well require this.
Again, it's the might as well. It's this is why I said it's convenient to deploy it alongside, but there's nothing in the circuit that requires RCM to be computed in this way.
That is true.
Nothing. So it is still entirely possible that we could say this, and then someone upgrades to V6, implements V6, deploys the format, but does not alter how they generate RCM. The only way to do that would be an additional rule that basically that wallets reject and ignore funds that don't set RCM in this way. And that runs into basically the same problem as we had with ZIP 212, where you then just have to tolerate people breaking that rule.
Hang on though. So if a receiver doesn't implement the new HRCM, as it's called in the draft, then they will break for ZSAs as well as breaking for all quantum resilient notes. So they just have a broken wallet. That's not an acceptable implementation.
No, the HRCM, however you choose to produce, I'm forgetting which of the. We're going beyond what's worth talking about in the Arborist call now.
Okay.
Because it turns out
possibly, yeah. We need to discuss this in an R&D meeting.
Yes, because it sounds like you've made some changes beyond the last things we discussed in an R&D meeting. So
probably, yeah.
We need to talk about that.
We do, but I think I'll be able to convince you that there's no point in trying to maintain more compatibility than just requiring all wallets to immediately implement this before the network upgrade, and just checking that they do instead of what we did in Canopy, which is kind of wishing and hoping.
Which again, it comes back to this is why it would be useful to deploy this alongside a new 7.
But
I
think we need a longer testnet period than we had for Canopy.
Yes. Yeah. And so in part, it's going to come down to like how quickly is this available and implemented and people can actually test and use it.
Yeah, exactly.
Compared to everything else that needs to be done for a new 7.
Right.
That's going to be where what that comes down to. But this would definitely, but again, it would be riding alongside a U7. And if we can't make it work on that timeline, if there's too much other stuff to do and we can't get it in, then we will just have to find another way to mark the upgrade, whether that is roll it out concurrently with a data network upgrade.
I mean, if I have to write the code myself, I want to make sure that this gets in. And all Libra Zcash using wallets, it will just work because they're going to be using Zcash native encryption.
Yeah.
But also because of memo bundles and because memo bundles are in the same upgrade as CSAs and quantum resilience, everyone is basically going to have to completely re-implement note encryption. Why would they implement it ignoring one of the specs that we say you've got to implement? It doesn't make sense.
I point back to the earlier comment I made when we were talking about the Zcash test vectors, where people did precisely this.
Okay, fair.
And hard-coded parts of the transaction format to 0.
It would never have occurred to me that someone would do that.
That's why I bring it up. People do indeed do. They take the path that works for whatever it is that they are trying to achieve in the moment. And yeah, we hold ourselves to a very high standard in the Zcash community. And
I mean, true, but this protocol is so complicated that you basically have to implement to the specs. I think part of the issue there was that the implementations that broke, they had never sort of held themselves to the same standards as the code that we write. Sorry, that's controversial to anyone still here who was implementing those wallets, but it's my opinion.
So if a wallet ignores the RCM computation, it simply does not detect a new incoming node, right? It basically loses.
I mean, so what I plan to say is that from NU7 onwards, the producers of note ciphertext must use lead byte equals OXO3, which means that all notes would fail to be received by a wallet that didn't implement OXO3. So that is just a broken wallet. And presumably users will notice that it's broken because they are not getting any incoming funds. The problem that we had with Canopy is that we allowed 2 different versions.
It wasn't that we allowed
okay, all right. That's an oversimplification.
The problem was that we only allowed version 2 too soon.
I don't think that was the problem. I think the problem was inadequate testing.
Yeah, I think it's reasonable to specify spec for the wallet and expect people to either adopt the official code or implement it
Yeah.
according to spec. It is reasonable. Okay.
And also all of the lengths are changing, so they can't use the old implementation. It won't even pass the transaction. The thing about Canopy is that it was too similar to the previous protocol implementation, so you could get away with not changing it. Here, you can't possibly get away with not changing it. Okay, so that's my argument anyway.
I think that's we're at time. I'm not sure what the proper venue to continue this is. I'll let you guys.
Oh, R&D meeting.
Yeah.
R&D meeting. Okay. Perfect. Well,
Yeah.
thank you. That was quite interesting. Let me jump to the slides. Yep. Thank you for joining today. And the next Arborist call is September 18th at the 1500 UTC time slot. Thanks, everybody.
Bye.
Thanks. Bye.
So, yeah.
Bye.